1 second, sir. Let me check. Sir, from October 5th, it's starting.
October 5th. Okay, yeah. So we have ample amount of time, right? It's 14th of September, so we have a good amount of time. So we will finish this seventh chapter quickly, and then we'll do some questions, right? So practice question. Okay, so let us start,
Okay.
right? And yeah, so let me. Yeah, so you were not present in the previous class, so let me just recap some portions of that, and then we'll go ahead. So in the previous class, we understood that there is an industrial application or there is a huge application of electromagnetic induction, whatever we have learned in the sixth chapter, right? So electromagnetic induction we understood because we change the flux and then there is some EMF generated, right? So we can use those principles to for a commercial purpose, right? So we have these AC generators, which we can mechanically move the coil and then we can generate some EMF. So that was the idea of the AC generator. So in the previous class, we understood that using the electromagnetic induction, right? So in the AC, we rotated the coil because phi is BA cos theta. So keeping this magnetic field and A constant, we change this theta. So due to this rotation of theta, this flux got changed, and then we generated the EMF. And finally, we found out that this EMF had a sinusoidal behavior. So where this omega is the angular frequency or velocity, right? And this is for one full rotation. So let's say for one full rotation, the angular distance that you cover. How much is the angular distance, Aisha, for one full rotation?
You can
Yes,
say
yeah, 2 pi. So the angular rotation theta is 2 pi, and time takes is t, right? So then this omega we found out was 2 pi by t. So and then we know that we calculated this EMF. So this was the instantaneous EMF, right? And then we understood that this was the maximum value. So this was the maximum value, also called the amplitude subtime. And this was the angular velocity. And we can clearly see that this is behaving like a sinusoidal. So this has a sinusoidal behavior. So when we plot the graph, so this will come out to be, so from this is 0 and then this is t, and this is the variation of t, right? And this is the time. And this is what we call the maximum, which was E naught. And this time is T by 4. So this we did in the previous class path, and we also learned that when we calculate the average, when we calculate the average EMF in full cycle, so the average of anything, let's say if we want to calculate this is fx, some function of x, right? And let's say this is y, which is some function of x, and we want to calculate the average of y. So average of y is represented by this notation, and this would be fx dx from 0 to x and divided by total x. But in this case, this is t, right? This is t, so this would be 0 to t ft dt, and then this is t. So this is the definition of the average, right? Let me write it properly. So this is ft, this is dt. So this is the definition of average. And similarly, when we calculate average in full cycle from 0 to t, which is the full cycle. So when we calculated this, this was 0 to t and e dt divided by t. This is the definition of average, right, Saad? Understood? So this is your y. So average of y is y dt 0 to t divided by t, right? And we know that value of E we already calculated. So that is E naught sine omega t dt 0 to t and then t. And when we calculated this integral, we found out that value of average EMF over a full cycle was 0. So this is the part that we did in the previous class, right, Aisha?
Yes.
Yeah. So Saad, if you want to take a screenshot of this portion, right, you can take or you can go back and see the video, right? Previous video. Okay, so this much we did in the previous class. Now, what we are doing is that, so now the question is that what is the average EMF? Oh, who got disconnected? Okay, who got disconnected? Everyone is there. So average EMF in half cycle. So we have this behavior of the EMF, which is this, right? This is from Z0 to T. So this is the full cycle. What would be the time for the half cycle? So this part is half cycle, right? So what is the time in here? Yes, guys, what is the time in here? Total is T. So this would be how much? Half cycle. T by 2. So this is T by 2. So we have to calculate the average EMF in half cycle, meaning 0 to T by 2. So everything would be same, right? We want to calculate again average in half cycle. So this would be 0 to T by 2 and then E dt divided by T by 2, right? So now we have to calculate this integral. So this would be E naught sine omega t dt and from 0 to T by 2 divided by this 2 goes in the numerator and this is T. So E naught is constant. We can take it outside, right? Now, this integral is 0 to T by 2 and sine omega t dt. And as you guys saw yesterday, so Saad was not present in the previous class, but the integral of sine omega t is minus cos omega t divided by omega. Whatever factor is multiplied here, in the integration that is divided, right? But the case for differentiation is different. So let's say that you have this d by dt of sine omega t. So if you are taking the differentiation where this is multiplied with the variable, then this would be cos omega t into w, right? So in the differentiation, this constant is multiplied, and in the integration, so this is sine omega t dt. So this would be divided. Understand? Understood, everyone? So this, how do we get this integral? This we had done in the previous class. So you guys please look at that. So we will directly use that, and this would be 2 e naught by t, and this is minus of cos omega t by omega, and from t by 2 to 0. So omega is taken outside. Omega is taken outside. This is multiplication. So minus t e naught and then t omega. And the limit is cos omega t and t by 2 to 0. Right. So first we have to put the upper limit. So what would be in here, Aisha? If I put uh, the variable is t, so I have to put the upper limit in the variable. So what would be in here? Yeah, first I put the upper limit. Yes, Aisha. Remember, function is cos of omega t, and you have to put the limit of t. You are putting the limit of t. So what would be in here?
I do.
Yeah, so t by 2, but function is cos omega t. So cos omega t by 2. In place of t, we have to write, right?
Yes.
So this would be cos omega t by 2 minus the lower limit. So what would be in here? Yes,
Cos
Saad.
omega t.
Okay, good. So cos omega into 0, right? Good. So then what do we have? Now we know that minus t e naught, and I can write the value of omega. What is the value of omega, guys? What is the value of omega? Remember, for full cycle, what was the angular distance? What was the time? So keeping that in
2
mind,
by
2 pi by t, right? Good. So this is 2 pi by t into t. So this t cancels. And again, we put the value of omega. So 2 pi into t divided by 2, right, into t. So this t cancel, 2 cancel. Minus of cos 0. So this 2 cancel, and we have e naught by pi, and this is cos pi minus cos 0 is how much? Cos 0, everyone. Cos 0 is 1, right? Yes. Okay, and what is cos pi, Saat? Do you remember cos pi? What is cos pi? Yes. What is cos pi? So cos pi is -1. Okay. So this would be minus E naught into -2 divided by pi. So minus minus cancel. And oh, Saad, you wrote in the chat box. So, oh, don't know. Oh, why? Why are you crying? So, if you don't remember, then it's okay, right? We have to just remember it again. Okay, so 2 E naught by pi. So, this is the average EMF in half cycle. Let me write it half. So, understood everyone? Is this part clear or do you guys have any doubts? Yes, guys? Okay, so if you guys don't have any doubts, so then please note it down from here. Oh, what is average? This is average. Okay, please note it down, guys. So we are calculating the average up to this point. Oh, this is not. What is the color that is? Yeah, I get it. Yeah. So we are calculating the average in this region. Okay. Whenever you guys want me to scroll down the screen, guys, tell. Where is Mariam? Yeah, whenever you guys have completed noting it down, please tell. So that I can scroll down the screen. What disconnected again? So which one of you guys has mathematics in your 12th? Yes, Aisha and Saad. You guys have mathematics in 12th.
No, sir.
Okay. Okay, then you have not studied this integration. So if you guys feel any doubt in the integration part, please ask. Right?
Yes, sir, can you scroll?
Oh, you have Saad, you have mathematics. Good. So which means you know the integrations, right? So have they started this integration chapter? Differentiation, obviously they have started, but did they start this integration? Oh, good, good. So now you'll be able to understand. And yeah, so yeah, it's easy. So in comparison to differentiation, integration is not that easy. You will have different kinds of integration. So then you will see this is not that. Differentiation is pretty easy. Integration has some, yeah, so it is quite. Okay, and I saw whatever we need in the integration part that we have done in class, right? So, but if you math is the only subject you like, oh, good, good. Okay, so physics is also mathematics, applied mathematics, right? So just the integration of physics is just the integration of mathematics. Okay, whenever you guys have noted it down, please tell. So
Nonsense.
you don't like physics, you find it hard, sir. Okay, maybe I'm not teaching that good, that's why you're finding it hard, right? Because it's the sole responsibility of the teacher that makes you understand the subject. So we will work on that stuff, right? If you are finding it hard to understand something, then we should work on that. Because the subject interest comes from the teacher who teaches that subject. So yeah, whenever you guys have finished, please.
Nonsense.
Done. Saad, what about you? Okay, okay. Please note it down. Done. Good. So now let us do one question so that we can understand. So the EMF generated by the generator is E is let's say 14 sine 5t. So this is your E, right? And you have to find out. Question is that find the maximum and find the maximum EMF and angular velocity of the EMF. Second thing is that find the average EMF in a full cycle. And the third question is that find the average EMF in half cycle. Right. So you have a question where the EMF is represented by E is 14 sine 5t. So if we compare it with the standard form, E is E naught sine of omega t. So if we compare, then we can say that E naught is 14 and omega is how much? 5. So these are the maximum and angular velocity of the air. Right, everyone? So this is question number 1. And then second is average EMF in a full cycle. Right. So this we already know, that is 0. And then third question is average EMF in half cycle. So that is how much we have calculated. That is 2 E naught by pi. Right. So that is 2 E naught is 14 and pi is 22 by 7. Right. So this would be 11. So this is 98 by 11. Right. And volts. Okay. So is this part clear, everyone?
Yes, sir.
14 volts, and this is rad per second. Right. So you guys please note it down, and if you guys have any doubts, please ask. Yes. If you guys have any doubts, please ask. Otherwise, please note it down. And whenever you guys have noted it down, please tell.
Done, sir.
Done. Saad, what about you?
Done, sir.
Good. So the next thing, so we calculated up until now, we are calculating or we were calculating the average EMF. So now, before we do any calculation, let me ask you guys something. So Saad, you have mathematics. So this question is for you. What is cos 2 theta? Yes. What is cos 2 theta? Hmm. What is cos theta 2 theta?
Yeah, sir.
What is cos 2 theta?
Cos square theta minus sine square theta.
Oh, good. So, right, cos square theta minus sine square theta, right? And we can write it as 1 minus 2 sine square theta, or we
Yeah.
can write it as 2 cos square theta minus 1, right? Good.
Yes, sir.
So, good. And which means that we can write cos 2 theta as 1 minus 2 sine square theta. Okay, so we will use this one. Good, good. So, you remember, right? So, what about the physics? Okay, good. So we will use this relation, right? So the next thing that we want to calculate is root mean square EF, right? What is root mean square EF? And it is represented by, oh, so we have to make some profit, right? You are at loss, so we have to gain some. Okay, so we will revise some portion of physics, and which portion you are not able to understand, Saad? Which chapter is giving you some problems? Which one? Don't say all the chapters. Yes, okay. Because you have to be regular, right? If you're not regular, then physics is a very linked subject, right? So every topic is linked with the previous one. So if we miss one topic and we go to the other topic, then we won't be able to, because there is a chain. And if we are breaking the chain, then that would be. So in that way, we have to be regular, right, sir? Yes. So for Aisha, second chapter is problematic, right? What about you, sir? For you, which chapter, what is the chapter that is making you uncomfortable? Okay. Yes, you said 1 second and then okay. So which chapter? Some topics from the second chapter. Good. So one day I will start or I will start revising this chapter. Right. Second chapter. So potential one. Okay. So now let us come to this root mean square. Right. So let's say we start with here. So we have this EMF, right? And we go backwards, right? So we have this EMF, then we square it, then we take the mean, and then we root it. So that is called the root mean square EMF. Understood, everyone? Understood? So we have this, what is the EMF that we have? We have this E, which is E naught sine omega t, right? Now we have to square it. So let us square that. And we have to find the mean of this square, right? So how do I find the mean? What would be the mean of this E square? Can you guys tell me? Whatever is the function, how do we find the mean? So yes, Aisha and Sar, you guys tell me, what would be the mean? Yes, yes, Aisha and Sar, please, this we just understood. We calculated two types of mean. Average mean in half-life, average mean in full cycle. So how did we calculate the mean? Yeah, let me have you. So y mean was what? It was y dt from 0 to t divided by t. This was the mean, right, everyone? So looking into that, what would be this mean? Please, guys, tell me. Yes, doubts, any confusion? Okay, so let me, because you see function is v square. So this would be 0 to t integral, right? So 0 to t integral and then e square dt by t. This would be the integral, right, everyone? Understood?
Yes.
So now we just plug in the value of this is 1 by t from 0 to t, and then this is e naught square and then sine square omega t dt. Right. So e naught square is taken outside, and then this is by t. And this is from 0 to t sine square omega t. So we cannot take the integral of this sine square. Okay, we cannot take the integral of the sine square. So we have to change it in the without power form, in the linear form, right? So as Saad has said that we can write cos of 2 theta as 1 minus 2 sine square theta. So I can find out what is sine square theta in the form of linear form, not the square but the linear form, right? So this would be 1 minus cos 2 theta divided by 2 equal to sine square theta. Right, Saad, am I correct? Yes, Saad sir, is this correct? So I just put the one value in this side, take the negative sign, divide it by 2. So then I'll get this one. So I can put the value of sine square theta from here. This would be E naught square by T 0 to T and then 1 minus cos 2 theta, which is cos 2 omega T divided by 2 and then T. So these are two different integrals, 1 by 2, and so I have to separate these two integrals. So then I can write this as E naught square by T 0 to T. Let me take the first integral, which is 1 by 2 dt. And then the other integral is 0 to T cos 2 omega t divided by 2 dt. So these are the two integrals, right, guys? So first, we take the integral of this one, e naught square by t, and 1 by 2 is constant, so it is taken outside, and we are taking the integral of dt. So this would be t, right? And this is half is outside, and integral of cos 2 omega t dt. Okay. So integral of dt is how much, guys? Integral of dt. There is no function in here. 1 multiply. The integral of dt is t, right? And in the limit t to 0. So this is the first one. And what is the integral of cos 2 omega t? What would be the integral? What would be the integral of cos 2 theta? What would be the cos integral? Okay, so let me ask this question. What is the integral of cos theta? Sin theta, right? Good. So sin theta. So this would be sine of 2 omega t. But what is multiplied with t? 2 omega. So this would be divided by, this is an integral, so this would be divided by 2 omega and t to 0. Who got disconnected? Oh, Saad got disconnected. So, okay, so let us go further. So this is half. And if you put the limits, what would be the answer, Aisha? If you put the upper limit, so in place of t, we have to put t. So what would be there? Yeah, what would be in there? T minus 0, right? So t minus 0. Good. And this is half. And 2 omega is outside, so 4 omega. And this is sine of 2 omega. And in place of t, we have to put t. Minus of sine and 0. So let me write it as 0. Clear? And then the bigger bracket. So this would be E naught square by 2, 1 by 2 t, and minus of 1 by 4 omega. Sine 0 is 0. But what is sine of 2 and omega is how much, Aisha? 2 pi by t. Good. So 2 pi by t into t, this part cancels, and we have sine of 4 pi. So this is E naught square by t and 1 by t and 1 by 4 omega sine of 4 pi. What is the value of sine 4 pi? Yes. What is the value of sine 4 pi? Remember, sine is this function. So this is 0, this is pi, this is 2 pi, this is 3 pi, this is 4 pi. So sine of my integral multiple of pi is how much? Yes. Sine of any multiple of pi would be 0. Understood? Because sine function is 0 at these points. Understood, Aisha? So this is cancelled, and how much do we have? E naught square by 2 and then 1 by 2t. So t cancels, and we have E naught square by 2. So this is the average of mean of square, right? Now what do we have to calculate? We are calculating the square and then mean and then root. So root, mean and square and EMF, right? So let us calculate that. And this is represented by RMS, root mean square. So this is E naught square and root, right? So EMF, then square, then mean, and then root. Oh, Mariam is joining now. Okay, so yeah, so we have calculated the value of E naught square divided by 2. So this would be E naught by root. So this is the RMS value. Okay, understood. Understood, Aisha.
Yes, sir.
Okay, yes. Hello, Mariam. Assalamu alaikum. Yeah. Hello, Mariam. Can you hear me? Yes. So, yeah, you have joined very late, right? So we just in the previous class we calculated the average EMF, average EMF in full cycle, and we calculated it to be zero. Oh, you overslept, so you got tired of something. Okay. So now in this class, we have calculated average EMF in half cycle, and now finally we calculated root mean square EMF, right? So root mean square EMF when we go in the backward direction. So this is EMF and then square and then mean and then root. So this is how we represent the root mean square, right? And we have this E, so we calculated the E square mean and then we calculated the RMS. So you guys please note it down. And if you have any doubt, oh, you just joined. So please note it down, Mariam. And if you have any doubt in the if you have any doubt that is coming into your mind while noting it down, so please ask. Okay, so yeah, please you guys note it down. Oh, this part is so this part is start noting down from here. So this is ER. And whenever you guys want me to scroll down the screen, you guys please tell. Yeah. So should I scroll down the screen?
Yes, sir.
Okay. So please note it down. Yeah. Whenever you guys have finished, please tell.
Done, sir.
Done. Okay. So then please note it down.
Done, sir.
Done. Yeah. So this part. Done, everyone.
Yes, sir.
Done. Okay, so let us do one question and then we would be able to understand everything. So we have, so the AC current, or let me write it as AC EMF in a circuit is represented by, let's say, E, or E is 40, not 40, let me write it, 11, 9, and 20. Right. This is the EMF which is given, and we have to find out what is the peak EMF. Right. Peak is the same as, so where are you getting the peak? So this is the peak, which is same as, my voice is cracking. Okay. Uh, oh, who got disconnected? Yeah, is my voice cracking, Aisha?
No, sir.
Okay, so yeah, she got disconnected. So we have to calculate peak EMF, and then we have to calculate average E in a full cycle. Third one, we have to calculate average E in half cycle, and then we have to calculate ERMS. Oh, not like this, but ERMS, and fifth one, the angular frequency or velocity. Okay. So please, yeah, Aisha, you please calculate these things and tell me the answer. Right. So peak EMF, you can directly say, what is this peak EMF? Yes. What is peak EMF? Yes, Aisha, what is peak EMF? Are you saying something? I cannot hear you. Yeah, so I cannot hear you properly, Aisha. What is peak EMF in here? 11. Good. So 11 is the peak EMF because we have this E naught sine of omega t. So when we compare this with this one, then we'll get this. Average E is 0. E half is how much, Aisha? E half is how much?
No, we know that.
Yeah, so 2 E naught by pi. So this is 2 E naught is 11 by pi is 22 by 7. So this is 2 and then this cancels. So we have 7 volts. This is 7 volts. E RMS is E naught by root 2. So 11 by root, right? And angular frequency omega is 20 rads per second, right? So these are the things, and you guys, you please note it down, Aisha, and then we'll understand the next topic. Whenever you have noted it down, please tell. Whenever you have noted it down, please tell. Noted.
Yes. Are you not audible?
Yes, can you guys hear me now? Am I
Yes.
audible? Okay, good. So yeah, Mariam, you please take the screenshot of this question. So we had this EMF which was given like this, and then we calculated these things, right? So please take the screenshot and then we'll do the next topic. Okay, so note taken the screenshot, Mariam. Yes. Okay, good. So now, now let us do this. The next topic is phasor and phasor diagram. Right. So what is this phasor and why do we need this phasor diagram? Right. So let's say that we know that in our case, what is this EMF? EMF is E naught sine of omega t. So this behavior of EMF is how it is sinusoidal, right? So whenever phasor is what? Phasor is what? Whenever a physical quantity is in the sinusoidal form, then it is called a phasor. Okay, understood everyone. So let's say you have this current which is I naught sine omega t, right? So you can see that the behavior of current is also sinusoidal. So these things are called the phasors. Understood?
Can you explain again?
Yeah. So whenever you have a quantity which is behaving like a sine function, right? So that kind of quantity will be called a phasor. So in this case of this EMF, so EMF is this is a constant, right? EMF. So this E naught is a constant and it is behaving or varying like sine omega t. So the diagram of the graph of this function is this one, right? So this is behaving like a sinusoidal form. Understood? So then this E is called a phasor. Okay. Similarly, you have a current. So this current is, let's say this is behaving like this one, right? So this is also in the sinusoidal form, right? So this current will be also called a phasor. Understood?
Yes, sir.
Okay. So, and what is a phasor diagram? So in phasor diagram, we represent the differences between the two quantities, right? So in our case, we will talk about the differences in the current and the EMF, right? So let's say you have a quantity. Let's say you have this EMF, which is E naught sine of omega t. So this thing is called the phase of. So this is called the phase, right? And let's say you have a current which is flowing like I naught sine omega t plus pi by 2, right? So the phase of current is phase of current is omega t plus pi by 2. And phase of this EMF is how much? This is phase of EMF. This is omega t. So if we calculate the difference between the phases, phase difference, right? So this would be how much? This would be omega t plus pi by 2 minus of omega t. So that would be pi by 2, right? So generally we write the phase difference, right? So generally we write, okay, we'll talk about the phase difference in the next topic. But this part, how do we represent these two things, right? So this will be done by the phasor diagram. So what we do is that we represent, let's say this is x and y axis, and this is the angle that it represents, right? So what is the angle of EMF? What is the angle of EMF? That is omega t. So this is represented by omega t, and this arrow will represent the instantaneous EMF, right? So which is E. And when we drop down to the y-axis, when we drop down this arrow to the y-axis, so this would be given by E naught. So this is the phasor diagram of phasor diagram of EM, right? Which is this part clear? Is this
Yes.
part? Similarly, let us write the phasor diagram of current. So we have this current, right? So you remember this is omega t. So omega t plus pi by 2, right? Omega t plus pi by 2. So 90, we have to add 90-degree angle. So this would be in the second quadrant. And the arrow is small, right? So this is I, which is I naught and sine omega t plus pi by 2. Because this angle is omega t. So this whole angle is omega t plus pi by 2. Okay. And when we drop down this part in the y-axis, so then we'll get I naught. So this is the phasor diagram of current. Any doubt in this part, guys? Any doubt?
Mm.
Okay. So now we can combine these two graphs and we can write them together. So this is the beauty of this phasor diagram. So we have this voltage, right? And this is omega t, and this is E. And when we drop down this, so this is E naught. Similarly, we have this, we know that is current is I naught omega t plus pi by 2. So this is in this direction. Or let me, so this is this is I, and this is I. So you can see that value of E naught is greater than value of I, right? So this is and from here, you can see that the current is, from this diagram, what you can see. So phasor diagram of current and EMF. And from here, you can clearly see that current is pi by 2 ahead of E. Is this clear, guys?
Yeah.
Yes, yes. So this current is pi by 2 ahead of this voltage here, right? Okay, so if it is clear, then you guys please note down this part. So yeah, please note down. Oh, again Mariam got disconnected. Okay, so Mariam has some problem with the internet. Yeah, so whenever it is completed and you want me to scroll down, please tell me, Aisha.
Done, sir.
Done.
Done, sir.
Done. Noted.
Done, sir.
Okay, so note. Yes, Mariam, you got disconnected again. Yeah, your internet is fluctuating. Okay, so Oh, when you were there, yeah, you were there when we were doing the phasor diagrams. We just commonly represented the current and the EMF. Oh, you finished this. Good. So completed, guys.
Yes, sir.
Good. So then in